One of the most fundamental things you need to learn when learning how to program is how to handle data. Essentially, all a program is you giving the computer some amount of information, it performing some tasks, and then giving you back information. Well, in order to do this, you have to tell the computer what type of information you're using, because Java is a strictly typed language. So essentially, there's these categories of information that turn into Java keywords so we can tell the computer this is the type of data I'm working with. Here are the primitive data types. So we have things like numbers and int, which is a number without decimal places, and double, which is a number with decimal places. Then we can have things like chars or characters, which is just a single Unicode character. And then we can have a Boolean, which is just true or false, which comes into play when you're doing logical choices later. You may also be familiar with data types that are objects, like strings or arrays or scanners. These are also data types, and you'll use them in the same way that you'll see us using the primitives. So once you have some data, chances are you're going to need to do some work on it. So one of the ways that you're going to do that work is with expressions. This is for things like numbers, where you're going to manipulate them based on a set of operators. Here's an example. Generally, the operators follow what you're familiar with when using your calculator. Here are some of the other operators that you can use: addition, subtraction, division, multiplication, and the modulus operator, or the remainder operator. You can hit some kind of tricky situations when you're dealing with ints, mostly because we know ints can't store decimal places. So what happens when you do an int expression that should result in decimal places? Well, what happens is that the decimal places just get dropped. We call this truncation. So in these cases, whatever decimal places should have been there, we just leave them off. If you do want to capture that information, that's one of the great uses for the mod operator, because it returns the remainder. So if you were to do the same expressions, but instead of using a divisor, you used a modulus, then you get the remainders. Of course, if you want to do a mathematical expression that does result in decimal places and you want to keep that information, use doubles instead of ints. Strings are also another type of data, but they can't really use all of the arithmetic operators like the numbers can. However, you can do some things with strings. For example, if you add two strings together, they combine. This is called concatenation. You can also add a string to any other type of data, and Java automatically converts the data type to a string. So a string plus a number results in a string. Here we have some code where we're creating some strings and then we're adding them together in the process of creating a println. Here's the output of this code. The first time we do it, we just add the two strings together. So they just literally kind of mush up against each other. The second time, we add a third string in there. And the third string is simply a space. Java is not going to infer that you want a space in your strings. So if you want to add words together like this, sometimes that's something you're going to need to do on your own, is to manually add in a space. Once you understand data types, now you can use variables. A variable is just a storage space in memory for a certain type of information. And that information can change over time as long as it's still within the same data type. The syntax for creating a variable is you start with the data type that you want to store, you make up a name for the variable, and then you set it equal to whatever information you want stored. That information can just be a direct number, it could be a string if that's the type you're making, or it could be an expression. Naming variables in Java follows the same convention as methods, meaning it starts with a lowercase letter and then you uppercase every subsequent word, no spaces. Here's an example. This is a variable of type string. Right now, it contains the words hello there, but I could change this over time to any string that I want and still refer to it by the same name, myString variable. I like to think of this as sort of boxes in memory, where you've got a box and that box has a name, and then whatever's stored inside that box can change over time. But it's sort of like the specialized place just to store this information that you can use later on. Once you have a variable, you can refer to it by name. It's kind of like making a new Java keyword. Here, for example, you can store the variable on the line above, then after every other line has access to that variable. So you could say create a string variable and then print it out by using that variable's name. Notice here that we did not put quotation marks between the parentheses of the println. That's because I want it to print out whatever is stored in my string variable, not the actual letters that form the word my string variable. So remember to leave off the quotation marks in the case of a string. You can also see below here where you're creating a string initially and printing it out, but then you can change it later on, and that change is reflected in the output. As you can see, you can change what is stored in a variable using the equal sign, but you just leave off the data type whenever you're ready to change it. You only use the data type followed by the name when you're creating the variable, and then anytime you want to update it, you just call it by name and set it equal to something. Variables are going to let you manipulate data in far more complex ways. The only problem with variables is sometimes they only exist within the parameters or the scope of a certain set of curly braces. So if you ever get a cannot find symbol method error pointing at your variable, it probably means you're trying to access it from a part in the program that it doesn't exist. This is a great thing to experiment with because slowly over time you'll get a better idea of where variables are visible and where they're not within your program. But ultimately, you're going to have to master variables if you really want to program like the professionals.